thank you for the invitation to participate in this session. I'm going to give you an overview of our testing and verification activities in Narec, which is the National Renewable Energy Centre of the UK. And I would like to start with this slide you have seen before during the day. So, according to our existing testing facilities, we are covering from TRL 4, 5, 6 and 7 more or less. But this is the actual situation. Our aim, our objective is potentially to be able to cover everything. I'm not going to tell you how now. It will be during the presentation. I will try to show it how this strategy will take place. A few words about the National Renewable Energy Centre, Narec, which is based in Newcastle. Well, we are an open access centre and we are operating world-leading testing facilities at the moment. There is a unique set of facilities, you will see it later during the presentation. We are focused on offshore renewables, so it is wind energy, it is also wave, tidal, and also electrical networks technologies. In principle, well, we are working with the industry with a general aim at, we are aiming at accelerating technology development in these fields. And we are open to cooperate with different customers, including project developers, utilities, manufacturers, but also we are already cooperating with universities, research organizations in the UK and also in Europe, and supply chain companies in general. What do? We do applied research, consultancy, testing and demonstration. This is the core of our activity. Technology development, mainly we help others to develop technology. System integration and performance verification. These are the generic type of activities we have. But our activities can be better understood if we analyze a little bit the context in which we operate. Europe is in the middle of a big change in terms of energy system. The energy systems in Europe, or system, if we want to call it that way, is going to be changed. That was decided some years ago. It is a very ambitious plan to change in a relatively short time all the way in which we produce and even in which we consume electricity. And then it is this strategic energy technology plan, what is called the SET plan, established a number of objectives, including reduction of greenhouse emissions, but also energy efficiency and a massive use of renewable energies by 2020, which is tomorrow in terms of energy. Because as we know, the energy sector, to change something in the energy sector takes a lot of time. Taking into account that the normal lifetime of a power plant is 20 years or 30 years or more, depending on the technology, decisions related to energy are tricky. And to try to have the ambitious objectives by 2020 is really challenging. And there are a number of elements related to this European strategy. There is the UK Action Plan. So there is a global strategy for Europe. There is a particular strategy for each member state, including the UK. And there are a number of elements to be considered here. For example, the European Energy Research Alliance, which is, let's say, the voice of academia, the voice of R&D to establish the priorities in this strategy. We are part of that. We are going to be part of the European Research Alliance very soon. This is the voice of the industry, the European Wind Initiative. It is, again, between the industry and the R&D community and the European Commission. The priorities are established in terms of funding, what type of R&D projects are needed to be able to reach these ambitious objectives of 20%, for example, for wind energy, 20% of the electricity consumption in Europe to be supplied by wind energy in 2020. That's really challenging. And there are similar objectives for other technologies, PV and so on. I'm going to concentrate today in wind energy. So we're in that context, and even more, there is a technology roadmap. Apart of the general objectives, there is a technology roadmap for each technology, for wind energy in this case, up to 2020, with different milestones to be able to reach these objectives. One of the very important elements here is testing. So testing facilities and demonstration projects are needed all over this path to really be sure that the technology is developed in the right way. With a little bit more of detail, but I don't have a lot of time, there are elements dealing with new wind turbines, bigger wind turbines that require testing and demonstration, offshore substructures like foundation, again with elements regarding demonstration and testing. So I mean, there is one important element here. With the state-of-the-art technology, we will not be able to deliver the 2020 objectives. So new technology has to be developed, especially if we take into account the cost of energy, the cost reduction that we need to achieve. We all know that there is a target for offshore wind energy in the UK of £100 per megawatt hour. Now we are around 140, 150. So there is a long way in a very short time. New technology has to be developed, but not only new technology, some more things about logistics and many aspects, but technology is there. New technology has to be demonstrated, bigger wind turbines, but it's not only about designing these technologies, about being sure that it's going to work from day one in an offshore environment, which is extremely challenging, as we all know. So that's the environment. It's really challenging. It is an accelerated change. And what is the value of testing in all this environment? Well, if you see in a very simplified way, when you design a new technology, let's imagine a new wind turbine. There is a design phase. Then there is a validation of this design. It could be component level or could be the full system later. But it's very important to establish a bidirectional communication between the design and the testing to be able to get some knowledge and to improve the design, to correct the problems and to get knowledge to be able to design in a more efficient way. And I would like to mention that even well-experienced companies with a long track record in wind energy and wind turbine development are experiencing new problems because we are entering into a completely different scale. We are designing wind turbines and testing wind turbines of 7 megawatts, 8 megawatts, which is really a new scale for everyone. So new problems appear, and you really need to update the tools you are using and even the testing procedures you are using, etc. So it's a new environment for everyone, even for experienced companies. From a different point of view, when we are talking about design and validation, there are different steps. You can start, and you should start, from a material type of verification. If we think about blades, for example, this could be composite material testing and verification. Then you go one step forward, which is sub-assemblies like bearings, for example. Again, they have to be tested. We are going to test one bearing, for example, in Narec in a few months. You go up in terms of complexity, you go to the level of component. Gearboxes also have to be tested, validated. You can go up, and then you begin to be in the level of subsystem verification, powertrain. This is one of our facilities, so we can validate the full nacelle. And then at the end, you go to the full scale turbine validation in the real operational conditions. But it's very important to be sure that both components and system is working according to the design conditions and specifications. And what are the main challenges related to testing that we see? Well, testing is about reproducing operational conditions in an accelerated way. So we cannot wait the 20 years testing. So we have to compress this 20 years time that the wind turbine is going to be operational in 2 months, 3 months, depending on the testing, or more if we can. So reduction of testing time is paramount, is very important. This has an implication in the cost of technology development, and is one of the drivers, is to be able to reduce testing time without losing the representativity. So we need to reproduce the critical conditions that this turbine needs to experience before going to the real life. And then customization of tests. This is about knowing what are the operational conditions and being able to translate operational conditions into testing configurations to really reproduce in the laboratory what the wind turbine is going to experience, even specific events. We're talking about floating wind turbines, 10 megawatt, subject to wave loading, wind loading, in a dynamic environment. That's extremely tricky, and we need to translate all that environment into a laboratory and apply the same forces or equivalent forces to really see what is the performance of the turbine, or what is going to be the performance of the turbine. But what is our strategy in Narec? The strategy is about trying to create value. It's not only about the assets, the testing facilities, it's also about knowledge. And the combination of both is what makes Narec attractive, we hope. What about the assets? Well, we have the best unique testing facilities in the world. This is the 15 megawatt drivetrain testing facility that has been inaugurated recently, last June, and we have received the first nacelle Samsung 7 megawatts. Nacelle is going to be tested during the next months. It's a milestone not only for Narec but for the UK. It's a very important milestone. We have a 100-meter blade testing facility, 50-meter blade testing facility with 6 years of experience, electrical labs, etc. And, well, this is a picture of the Samsung 7 megawatt nacelle arriving to Narec. That's massive, I have to say. You have to see that to realize the size of this. Another project we are developing at the moment as a complement to our existing portfolio of testing facilities is an offshore demonstration wind farm. It's 100 megawatts, will be 100 megawatt wind farm, 15 positions, and this is real life operational conditions. It's representative of round 3, and hopefully it will be operational in 2015. And that's like the last step where you are testing the technology in real life conditions. What about knowledge? Well, our objective is, to reach R&D excellence, well, through specialization and partnerships. And then I begin to give you part of the answer to this initial strategy of trying to cover all the TRL from 1 to 9. Well, it's obvious that we can't do it alone. It's not a single institution will be able to do that. But partnership is one of the strategies, is one of the key elements we consider. So, we begin to be recognized as world leading in some aspects. We want to be world leading in offshore renewables, testing and R&D. That's our ambition. We are ambitious. We want to be there. According to the assets we have, we are already there. But we want to exploit more this position and the unique position of the UK market. The UK market is the leading market for offshore renewables, no doubt about that. So there is also an opportunity to bring together the existing expertise that it is already in the UK around Narec and around our customers and the technology that has to be designed to be recognized globally as world leaders there. Our objective, as I mentioned, is to reduce time to market for the technologies and specialization. We have selected 6 areas, what we call knowledge areas. It's wind and ocean conditions, blades, drivetrains, condition monitoring, high voltage systems, and test and measurements. And we're going to specialize there. Test and measurements, why? Because we need to know how to measure, what to measure, to extract the best possible information out of measurements. And then partnerships with centers like NPL are really strategic for us. We need to know, because in some cases they are completely new, not new parameters, but the scale of the parameters we are measuring, 14 meganewtons in the force application, meganewton meter in the force application system is tricky to measure at that level in a dynamic way and things like that. Partnerships with universities, with UK universities, we have already started some partnerships and we will go further in this direction, also with R&D testing centres in the UK and outside of the UK. So at this moment we are creating the national and international network of partners. You are invited somehow, and I would like to mention that very openly. So we would like to have a strong network of partners in terms of knowledge, in terms of expertise, in terms of universities and R&D centers. This concept of knowledge areas, like this kind of ecosystem we want to develop, will include Narec researchers, external researchers coming from academia. We already have some of them, but we want to go more in this direction. But also researchers and engineers from the industry working with us together, developing some products, services, and new testing solutions for the sector. And that's my last slide. This is our position in terms of TRL today, with the assets and knowledge we have, between 4 and 8. If we consider this offshore demonstration wind farm, it will be covering including 8. But with our partners, R&D partners, we will be able to bring excellent ideas and excellent academic research into opportunities in this sector. And I think it is important to mention that a testing center is a unique place to meet to have together R&D, academic partners, and industry is a meeting place somehow, because testing is interesting for the academia to validate models and to validate theory, if you want, but it's also, of course, interesting for industry to validate the products finally. So it is a kind of meeting point, and there is an opportunity, a big opportunity around that to be together and to create these kind of partnerships. So, and also the European dimension is very important for us. It's part of our strategy. The European Research Alliance, we are already beginning part of it, and the technology platform is already giving us the contact with the European industry and our colleagues in the European environment in research to be able to discuss priorities together and to get access to big European projects. Well, that's all.